Hello everyone, this is Mohammed, and in this video I'm going to go through experiment number 2. Make sure that you have read the experiment before watching the video because I'm going to only be going through the main points. We saw in the last experiment how we can analyze circuits using Ohm's law, KVL, and KCL. So far we have only dealt with linear circuits that only contain linear elements. In this experiment, we will see how to analyze circuits with nonlinear components. So they are nonlinear circuits. So here's an example of such a circuit. We see that it contains a nonlinear device. This device could be a lamp or an LED, as we will later see. So how can we analyze such a circuit? We use something called the load line analysis. It is a graphical method, so we will be graphing stuff. We're going to be graphing two things. First, we're going to graph the IV curve of the nonlinear device, which is shown here in blue. Then we will graph the load line or the operating point, which is shown in red. Now, how do we get these two lines? For the IV curve of the nonlinear device, what we do is that we take this nonlinear device, put it in a circuit by itself, vary the voltage across it, and measure the current going through it. Now, once we do that, we plot the data and we get the IV curve of the nonlinear device, which is shown here in blue. Sometimes you can find this curve in the data sheet of the device. So here I have the data sheet for a diode. A diode is an electronic component that only passes current in one direction and blocks it in the other direction. We will deal with an LED in this experiment. An LED is a light emitting diode, so it is a special form of an LED. So if I scroll down through the data sheet, I would find this graph right here, forward current and forward voltage. This is the IV curve of the device. I will talk about what forward means in a bit. So basically this is the IV curve of the diode, and you can see how it is nonlinear. So you can either find it in the data sheet or you can construct it yourself. And now that we have the IV curve of the nonlinear device, how do we get the load line? Now we go to the original circuit that we are trying to analyze, apply KVL to it. When we apply KVL here, we find this equation. Now we call this the load line equation. Now we need to graph this equation on the IV curve of the nonlinear device. In fact, this looks like an equation for a line in terms of I and V, right? Now to do that, substitute 0 for the current and find the voltage across the nonlinear device, like this, and you get 1 point. And then substitute 0 for the voltage across the nonlinear device and find the current, and you get the other point. Now plot these 2 points on the IV curve and connect them with a line, and you get the load line. Now remember what we are trying to do. We are trying to analyze this circuit right here. We are trying to find the voltage across the nonlinear device and the current flowing through it, which happens to be the current flowing through the whole circuit. Now after we have graphed these two, we look at the intersection point. This point is called the operating point, and it will give us the voltage across the nonlinear device and the current flowing through it. So in this case, the voltage would be 10.5 and the current would be 12 milliamps. Now some of you might ask, why don't I just build this circuit and measure the voltage and current going through it? Why go through all this hassle? Well, this is because we need a way to theoretically analyze a circuit before we build it. We want to predict the behavior of the circuit, just like we did with Ohm's law. Remember, if I give you a voltage and a resistor value, you can predict the current using Ohm's law, right? This is the same thing. Now, if I give you a voltage, a resistor value, and an IV curve, you can predict the current using the load line analysis method.